Okay, guys, so welcome to this class here. So today we're going to look at work and energy. Now, to start with, we do work every day. We do work every day. Even right now, what I'm doing, I'm working. So work is not a certain word that is new to us. Work is something that we know and that we do every day. Even most of you where you are right now, what you are doing is you're doing some work. Now, when a force moves the point to which it is applied, it is said to do work. So I won't spend my time on work. Work is actually calculated as force times displacement. Now this formula is very, very important. This formula is very, very important. And one thing you need to know about this formula is that this force here and displacement must be in the same direction. And this is very important. Must be in the same direction. If they are not in the same direction, then you can't talk about work. What do I mean by they must be in the same direction? Let's say we have an object here. Okay. The applied force is here. This is applied force. Okay. And let's say what you've given us is this displacement here. Is this distance here 6 meters? Then you're asking me to find work. Well, since the force is here and you're pulling it in this way, I need to know this distance here, this displacement going this side. So it's this force and the displacement from here to there in that direction, not that one, because that one has no business in this formula. Work is equal to force times displacement, but displacement and force must be in the same direction. If they're not, then we cannot. All right, so if I have a block here and it's moving in that direction, let's say the applied force is 6 newtons and the distance from here to there is 3 meters. Then I can find work as 6 times 3. And what I'm going to find is work. Now remember, work, the units are joules. So it will be 6 times 3 joules. That will be work. If I have an object here and it's moving in that direction, and you say you're actually pulling it at a particular angle, you give me this as 25 newtons. You give me this as 25 newtons. And let's say you are doing it at a particular angle. Let's just say this angle is 60 degrees. And you tell me that it has moved, let's say 6 meters in that direction. Then I need to know this force here, the force in that direction. Because for me to calculate work, I need to say work is equal to force times displacement. It's not this force here. It's moving in this direction. So I need to know this work here, which using SOHCAHTOA, you actually say 25 cos 60, and then you're multiplying by 6. And whatever you find will be the answer that the work you're talking about. So please always bear in mind that the work you are talking about here, the force and displacement must be in the same direction. All right. So since, remember, work, when you are doing work, it involves some change in energy. Okay. It involves some change of energy. So bear also in mind that sometimes the work done is just a change in energy. Now, if I have an object here and it's moving in that direction. The change in energy that I'm talking about is the kinetic energy. So we have two types of energy. We have kinetic energy and we have potential energy. Kinetic energy is the energy of motion. When an object begins to move from one point to another, as long as you are talking about motion, then there's kinetic energy involved. Potential energy is the energy of location. It's an energy that is stored, waiting to be used. And mostly we liken it to a situation where you have put an object there at a particular surface with some height. Okay, so this object here, you release it falling down. So it has potential energy at this point here. And the moment it starts falling down from a particular height, so it is reducing potential energy. But if you are throwing it, it is going up. From here, it's going up there. There's this height there. We say it's gaining some potential energy. So it is falling, losing potential energy. It's going up, it's increasing potential energy. And these two energies are calculated as, kinetic energy is calculated as 1/2 mass times velocity squared. Potential energy is calculated as mass times gravity times height. So those are the two formulas that we'll keep on using under this topic of kinetic energy and potential energy. Now, if you are talking about the change, I would denote the change by that. If you're talking about the change in kinetic energy, then it will be the final kinetic energy minus the initial kinetic energy. That's a change. So this is the final velocity, and this is the initial velocity. That's the initial velocity. That's a change in kinetic energy. So the work we are talking about, if we are doing work, there's an object here, we are applying some force, and this object has to move. Okay, this object has to move in that direction. So the work we are talking about is just a change in some kinetic energy, because the work is also considered as just a change in energy, and in this case, the change in kinetic energy. So this is kinetic energy there. All right, with that said, there are two things that I want to talk about under the concept of work and potential energy before we go and answer some questions. The first thing that I want to talk about is that the units for energy is actually also joules. So the units for energy is also joules, just like the units for work. So it's joules, because remember I said work is a change in energy, so the units are the same. And then the other thing that I want to talk about is the concept of conservation. Now, under the concept of conservation, this concept says or uses the fact that the energy is not destroyed. Okay, energy is not destroyed. If you are doing work, energy will not be destroyed. It will just be converted from one form into another. If it is potential energy, it will be converted into kinetic energy. Now, this only applies if there is no external force. If there is no external force, the question sometimes clearly states there is no resistance. The only force which is there, the only resistance which is there is the gravitational acceleration in the formula for potential energy. This is a gravitational acceleration, which is 10. Okay, that is the only. If there's no any other opposition, there is no any other resistance. Potential energy is just equal to kinetic energy. If it is the loss in potential energy, it will just be this the same as the gain in kinetic energy. This only applies if there is no external force, there is no resistance. Okay, so if we have an object here, and this object is actually falling, okay, is actually falling, there is no any force acting on this object, okay, apart from this G that we have in the formula for potential energy, okay. So the loss, because remember it's falling, so the loss in potential energy will be just the same as the gain in kinetic energy. Okay, so potential energy will just be equal to kinetic energy because there is no resistance. If there is resistance, that's a case which is opposite to conservation. That's a case where you have a non-conservative system, which is just opposite to conservation. In this case, there is resistance. In this case, there is resistance. So potential energy is not equal to kinetic energy. So potential energy is not equal to kinetic energy. Okay, in this case, there's a resistance. There's external force, in short. There's another force acting on an object. Okay, so in this case, you are not equating these two guys here. And there's a formula that you actually have to be using, you guys. And that is work done by the driving force plus the loss in energy. Now, this loss in energy, you have to first of all identify which energy is being lost. Is it kinetic energy or it's potential energy? So the energy which is being lost is the energy that you put here. If it's kinetic energy, then you are finding the loss in kinetic energy, and this will be equal to the gain, whichever energy is being gained here. If it's potential energy, then you calculate potential energy plus the work done against resistance. So always remember this formula here. The work done by driving force plus the loss in energy. This may be kinetic energy being lost or potential energy being lost. This must be equal to the gained energy. It may be potential energy or kinetic energy being gained plus the work done by resistance. Now, these things are not new to you guys. Remember, work is equal to what? Force times displacement. This force, this work we are talking about here is a driving force times displacement. This work we are talking about here is actually resistance force times displacement. So this is not new. If it's kinetic energy we are dealing with here, we always have those things there. If it's a potential energy we are talking about here, which is being gained, we know it's mgh, where m is mass, h is height, g is gravitation, acceleration, and then v is final velocity, u is initial velocity. Now remember, I've talked about two things: the conservation system and the non-conservative system. The non-conservative system is where you have other forces acting on an object apart from the G in your potential energy. In a conservative system, you do not have any external force. Okay, so if that is done, then we can go to this question here. We can go and do a question in 2019 past paper. There's a question on energy. (2019) past paper. There's a question on energy. That should be question 2. It's not this paper, guys. I have to go to another paper. The paper is here. So let's pay attention to this paper. This paper says a train of mass. This is a train, which is an object. Sends a straight slope at that angle there to the horizontal with constant driving force. So we have a driving force. At a point A on the slope, the speed of the train is 45 meters per second. Point B on the slope is 500 meters beyond A. So this is the distance between A and B. That's the displacement that we are going to use here if you're talking about the direction from A to B. At B, the speed of the train is 42 meters per second. Now remember, these that you are seeing, the velocities are there because you need them in the calculation of kinetic energy. So there's a resistance force acting on the train, and the train does that work there. So the question says there's a resistance force. So remember, you are not using potential energy is equal to kinetic energy because there's an external force. So you are using the second equation that I wrote. Okay, then we are taught to find a particular angle. I'll write the question. So we are answering 2019 past paper. We are answering 2019 past paper. Now, we have a train of mass. We have a train of mass of 150,000. 150,000. This is a train here ascending a straight slope inclined at that angle there, which is our alpha degrees, to the horizontal with a constant driving force, the constant driving force of 16,000 newtons. That's a driving force at a point A. So let's call this point A. On the slope, the speed of the train, the speed here, which is the velocity here, is 45. That's a velocity, 45 meters per second. Point B on the slope is 500 meters beyond A. So let's say this is point B here. It's 500 meters. So this from here to there, this is 500 meters. That's what the question says. Then at B, the speed of the train is 42 meters per second. 42 meters per second. There is a resistance force acting on the train. There's a resistance force acting on the train, and does the work of 4 times. So the resistance, so the work done against resistance is given, guys, is 4 million. Yeah, joules. Remember its work. And then we are taught to find the value of this. So remember, let's just use that the equation I wrote, because there's an external force here, resistance here. So we are going to use the work done by driving force plus, now remember guys, this is moving up, right? This is moving up. So there's a gain in potential energy and there's a loss in kinetic energy. Remember, kinetic energy decreases if your velocity is decreasing. You can see here, your velocity is 45. Your velocity up there is 42. So there's a reduction in velocity. Okay, so if there's a reduction in velocity, we know that there's a loss in kinetic energy. So it will be plus kinetic energy is because that's what is being lost, is equal to what is being gained here is potential energy. So we have potential energy here. That's what is being gained plus the work done by resistance. This is a formula I wrote when we are dealing with non-conservative system, because there's an external force acting on the object. There's resistance. That's an external force. Okay, so look, guys. So how do we find the work done by the driving force? Remember, work is equal to driving force times distance. So work done by driving force is going to be the driving force. We have it as 16,000. The distance, we have it as 500. It's here, right? Yeah. So we have the work done by the driving force. How do we find kinetic energy? Well, kinetic energy is the change, guys. It's 1/2. What is M? That is a mass. The mass is 150,000. That's a mass. What's the velocity? So the final velocity, which is 45 squared minus 42 squared. That's just the formula I'm substituting in that, guys, for the kinetic energy. So when we do that, we're going to find the kinetic energy. Okay, we're going to find the kinetic energy, which you actually find, it will be negative, but you just write the positive one. That's the negative, it just means that there's a decrease. But when we are doing the calculations, you always have to write a positive one. Okay, so that's what we have, guys. That's what we have. What about potential energy? Well, potential energy is equal to mgh. Okay, so M is 150,000. What is G? Remember, G, guys, is 10. H is what we have to find. Remember, H is this H here. We need to find it. We need to find it. We have the work done by resistance. Yes, it's here, guys. So you can see that in the equation, we have that, we have this, we have that. It's only this part which has the part for H. So it's like we are solving for H. We have everything, guys. We have everything. So now we can go ahead and substitute it. So the work done, so we are saying this plus this, which is the kinetic energy, plus is equal to, here, you are going to write this. Where there's potential energy, you are going to write this. Where there's work done by resistance, it's already calculated, guys. It's already calculated. Okay, remember, work done by resistance is equal to resistance times displacement. We are given this. This is 500. This we are given as that. So if you like, you can even find resistance, but it's not important in our question. Okay, so now, after we have all that information, we substitute in, we are going to have 8,000, which is the work done by the driving force, plus the kinetic energy, which is 19,575,00, right, is equal to mgh. Your M is 150,000, G is 10. We have H plus the 4 million, guys, which is the work done by resistance. So you see, we can solve for H, right? We just take this side, and then we divide throughout by 150,000 times 10. And we'll actually find, so that's a task for you. We'll actually find that H is going to be, you have this 943/60. You can even use a calculator. You just find direct some decimal number. So that is your H. Okay. Now remember, we have to find an angle. This angle is what we have to find. Remember, we are given this distance as 500 meters. H is this that we have found here. So what can you say? You are given hypotenuse and the opposite. So that's from SOHCAHTOA. So it's this part here, you have opposite and hypotenuse. So we have sine alpha is equal to, opposite is your H here, over hypotenuse is 500. So your H, you are going to put that, right? Yeah. And so you're going to say alpha is equal to sine inverse, guys, of your H, which is this, over 500. And finally, you find your alpha as 1.80 degrees. That's the angle. So we found the answer. So remember, on energy, there are two things you should know. Okay, there are two things you should know on energy. So on energy, there are two things you should know. The first is, where there's no external force, there is no resistance. So your potential energy will always be equal to your kinetic energy. So here, no resistance here. You use that part. The second part is the work done by the driving force plus The energy which is being lost here is equal to the energy which is being gained plus the work done by resistance. We know the formulas for work, for kinetic energy, for potential energy. And that means you can solve any question under energy, guys. I challenge you now. Go and solve some questions from past papers on energy. Okay, so we're going to end here for today on energy, and then I leave you with questions to go and solve.